welcome to the stage Dr. Jose Ignacio Latorre, Chief Researcher at the Quantum Research Center at TII.
Good morning. So in the beginning, it was wonder. One night, there was a storm and suddenly a lightning, a massive transaction of energy between the skies and the earth. And then you said, wow, wonder. And then we tried to understand that. We made a kite, and we realized there was a fluid. And that fluid, later we call it electricity. And then we said, hey man, why don't you channel that fluid? And we make a lightning rod. And we protected our lives, and we saved lives. Or we went to Greece, and we discovered that there were some rocks with peculiar properties in magnesia, and we call them magnets. And then we play around. We made a compass, and this is from the Middle East in the Middle Ages. And suddenly we realized that this fluid, electricity, and the magnetic properties are related. And then we make an engine. And then you say, wow, electrical and magnetic properties are related. And then we said, what is this? And we came up with a theory. We came out with equations that relate electricity, magnetic fields, and the motion of charges. And suddenly, a new wow moment. We said, if we understand science, we can do many other things. And then we constructed engines that transform motion into electricity. Then we created communications because the electromagnetic field can transport information from one place to the other. Or we just check the universe, and suddenly we discovered that we have gamma rays coming from anywhere, and we understand in full detail how these things work. But we are not satisfied. The equations of electromagnetism are not the equations of classical physics. Why in one of them there is the speed of light, in the others not? Both should have the speed of light, because this is causality, and Einstein got here with relativity, but was not good enough to understand the atom. And then we went ahead and we discovered quantum mechanics, and now we are able now to make coherent light, to make laser light, to channel into optical fibers, to communicate through the world, to enter in our body to inspect, or we can even do it without entering in your body. We simply do a magnetic resonance. It's a cycle. It's wonder. Investigation, research, and therefore technology. And it will repeat forever. The more we know, the more wow moment we have. And we keep going like that. So let me go back to the beginning. Let me go back to the moment where humans look at the sky. What an amazing wow, precision. They are there, spots in the sky. They are eternal. They are there. My life will pass, they will remain there. Yet there are other bodies that move around, the planets. Amazing. I want to understand that. I want to make meaning out of that. So for instance, I invent a narrative that the perfections of the celestial bodies affect my life. We invent the zodiac in the Middle East. Zodiac only entered in Europe in the 10th century, coming from here. So we try to relate to that perfection. Actually, I wanted to quote Ulugh Bek as the first guy who tried to measure the year up to 1 second. And he made this amazing construction of a gigantic machine to measure the right angles for the position of the sun. Or later, we have Kepler. I'm choosing only a few of these guys. That in 1609, he understood that the area that you cross is equal at equal time. So for the first time, I'm understanding that the perfection has indeed a fantastic reason behind. So let's go back. We need something different. We need to understand that first, we need precision. Without precision, no science. Second, we need accuracy. Precision is that you repeat the same thing, you get the same thing. Accuracy is that what you get is the right one. In the year, there was an error of 58 seconds. That might be precise, but not accurate. We need repeatability. We need a language to encode all these thoughts. And indeed, the language is called mathematics. But we had no mathematics. So how we discover mathematics? Let me take the example of the circumference and the diameter. We try. It's 3. No, 3 times the diameter is not the circumference. Actually, you can play with ratios, because I take a rod, I take exactly the circumference, I make many times, I take the diameter many times, and I see the ratio that they are commensurate. So this is how we got to 22/7, then 355,113. This ratio has a precision for pi of 10 to the minus 8, which is amazing. But we need a name. We call pi in the year 1706 by William Jones. And then we need the sign equal. Did you ever thought that we need to write equal? This is very late. This is in the 16th century. Or we need the sign of infinity, and this is what Wallis. And suddenly we needed other things, and for instance, Napier, Bernoulli, Euler invented the E. It is funny that Bernoulli rediscovered E because he was doing finance transactions, and he had to understand a series of multiplications of interest rates. And Euler came with E pi I equals minus. What is I? I was discovered by a colorful person, which is Girolamo Cardano, in the year 1500. He discovered probabilities because he was playing dice and making money playing dice. And he was the guy also who invented I to solve cubic equations and make money in the competitions in Italy between the cities. But then we needed numbers. And the numbers is very confused where they came from. The ones that we call numerals were imported from Alexandria. They made from India, they came from the Arab country to us, to Spain. I'm from Spain, so I say from us in Spain. And it was the Pope Sylvester II in the 10th century that brought the numbers 1 to 9, but not the 0. The 0 was first used in Europe in the 13th century by Fibonacci. But then we needed many more things. By the way, I just wrote the first 5,000 digits of pi, for which we know that there is no closed formula, that we have to expand to get these digits. We have to use a series which is infinite. And we have computed, humans have computed 105 trillion digits of pi so far. But we needed many more things. We needed to understand the primes that we use nowadays to communicate with your bank. You create keys by multiplication of prime numbers. Or we needed calculus. We needed all the problems, algebraic geometry. We needed algebra. We needed to understand in detail algebraic geometry. We needed probability, statistics. We needed all the branches of mathematics. To some extent, the 23 problems of Hilbert that he formulated in the beginning of the 20th century, many of them remain unknown. So are we knowledgeable of mathematics? We are in the bare infancy of understanding mathematics. We are just starting. So we need now to go into abstraction, because we have understood wonder, science, technology, and we know that the language was mathematics. Can we go there? And this is an amazing journey that we are taking. As of today, as 2024, humans know that there are 4 laws. We know that there is a unique law for gravity. So it was Newton that understood that the apple falling and the moon both are falling. Both are falling. We understood electromagnetism is a unique force. Electric and magnetic are not two separate forces. There is a unique charge. Later, we understood there is radioactivity. We understood that there are electroweak forces. And I just quoted that the muon can decay into neutrinos and other particles. And then we discovered that the nucleus of the atom must be extremely strong, because the protons will have the positive charge and should repel. They form the nucleus. So it must be strong like hell. We have 4 forces. Have we tried to make a unique meaning out of them? Indeed. Let me collect them. And what we did is that the 3 forces, which are not gravity, are now, they were tried to unify. So our abstraction is trying to say there is a unique law in the universe. Have we succeeded? Not really. This is the grand unified theories. There were several candidates. they were not working well. We thought maybe we should unify all of them, gravity included. So we started with supergravity, and finally we tried what we call the theory of everything, where the candidate is string theory. Have we succeeded? Yes or no? The answer is that this is our knowledge. This is the standard model for the universe. These are all the interactions that I mentioned on the left. And if I were the guy in charge of making the laws of the universe, I would have made it simpler. Definitely, I would not have gone into this mess. And I think everybody agrees. So again, I'm pointing at the same thing. We are in the infancy of understanding. It's just the first steps that humans are making. Have we done this thing of string theory? Well, I will quote Susskind, Leonard Susskind, one of the best scientists in the world, and he says, we should start again. Okay, it was a good try, but maybe we have to start again. So nobody saw it coming, I think, that there was another piece, not related to natural sciences, that we now call information theory. And this was done by a number of people, okay? Maybe you recognize some of them, Alan Turing II, maybe you don't know Church, but you should know Gödel, you should know Shannon. All your phones are encoding information according to Shannon's theorem, so he's a good guy. And we have learned to learn. This was the beginning of understanding information. We understood cellular automata. We went into neural networks. We went ahead, and now we question, can we generate artificial intelligence? And the answer was, some people say never. Humans are special. Some people say, well, maybe we are not that special. And we have learned little by little winters and springs of artificial intelligence. In the year around the millennia, we discovered deep neural networks, deep learning. Suddenly, we understood what is called the transformer architecture. We understand that we have to learn the long-distance correlations in the data, and then you are there. You are there. So again, let me say, we are doing the baby steps of artificial intelligence. Do you think that we will not have intelligence that will be general or larger than us? Please, this is the beginning. Of course we will have those things. So actually, to make my point stronger, let me put this huge thing, which is expanse today, Newton, over there. So barely around 350 years. Let me now compress 350 years, a factor 100. Okay? Let me do it. That's a yellow piece. I've done it. By the way, it's done at scale. So I've done it. I checked, and I did it at scale. Now, in the equivalent period, which is now 35,000 years, somewhere here we got agriculture, which, as many people say, is when we became slaves, okay? Because we had to move around, we had to produce the crops. Guess what? Why don't I compact 100 times this? I do it. Oh, the yellow. Believe it or not, I put it there. But it is not 1 pixel in this screen. Okay? It is not 1 pixel. So all our Newton is invisible here. Okay? It's nothing. So the Homo appeared, okay, 2 million years ago. Can I shrink it further? Of course. And the boss were people like trilobite. Okay? The results of the Cambric period. The explosion, where nature tried the sea star with symmetry of 5 legs, where the octopus with 8 legs appeared with 3 bodies, with us, with the 2 thing, with the symmetry bilateral, where nature was experimenting how life would work. Okay? So everything was tried there. I'm not going another 100, but that would be a little bit more than the age of the known universe. Okay? But we are nothing. So I repeat now. Are we in the end of science? We are absolutely beginning of science. Everything is to be discovered. We are just exploring nature at scales of 10 to the minus 18 meters, and there is an infinite there. Energies of only a few GeV. There is an infinite there. We don't know anything about quantum gravity. We don't know about the beginning of the universe. We cannot experiment with that. We are just building machines that will grow and be better. But we live today here. So what is next? So let me say the following. We only live an epsilon. Okay, we only live an epsilon. But what an epsilon? So at least for me at TII, we came here 4 years ago, and now we have Sana and James have built a tracking station for quantum satellites. We have created Josephson junctions, and our first qubits that control matter are the way that we follow quantum logic. We have done, you see the nail pointing at the point. That point is levitating. You can measure accelerations. We have our labs. We have our algorithms. We're solving problems that were not solved before in this way. We are using quantum logic. We are making everything, and we are partnering with the best in the world. So the right pictures are not ours, are of the best people in the world. So what an epsilon of time. It's an amazing, it's a privilege for us to be here and to be conscious of our history, understanding our limitations, but making science, making history. This is what we are doing. So let me finalize with this comment. Indeed, we are here now, us. What do? You know what? We have created all the logic of artificial intelligence. And we have built the machines that compute, the classical machines, one big avenue. We have understood the laws of quantum mechanics, and we are building the machines that operate with quantum mechanical laws. And they are converging to us, and now we talk. And we talk to the people that do computational biology. And we will now understand, not just write the letters of our genome, but understand it. We have the book, we have to learn to read the book. We are understanding that we can save energy. It's absolutely necessary, we use less energy. Absolutely necessary. And then we have fluid dynamics, quantum chemistry, finance. We have a new go into all these things. So I hope you want to work with us, because this will be great. Thank you very much.